Hello everyone, we are from Group 12 and today we are going to present about the bipolar junction transistor. BJT is a three-terminal doped semiconductor device that is generally used in the amplification of signals and switching operation. There are two types of BJT, which is the PNP and the NPN. Based on the schematics, it has three terminals, which is the emitter, base, and collector. This is how the side view looks like for NPN type of BJT. Vice versa labeling semiconductor type for PNP. Next, the symbol of BJT is illustrated such as above. We can differentiate what type of BJT it is by looking at the direction of current on the junction between the emitter and base. The acronym of BJT stands for bipolar junction transistor. Bipolar refers to the manipulation of elements of free electron and holes of the semiconductor. Junction is for the two junctions on the BJT where recombination occurs. Transistor is the transfer of resistor. When J1 is forward biased, the resistance will be low. When J2 is reverse biased, the resistance will be high.
BJT operation modes. The transistor can be operated in three modes. First, cutoff mode, second, saturation mode, and third, active mode. In order to operate transistor in one of these regions, we have to supply DC voltage to the NPN or PNP transistor. Based on the polarity of the applied DC voltage, the transistor operates in any of these regions. Applying DC voltage to the transistor is nothing but the biasing of transistor. In active mode, one junction, emitter to base, is forward bias, and another junction, collector to base, is reverse bias. In other words, if we assume two PN junction as two PN junction diode, one diode will be forward bias and another diode will be reverse bias. The active mode of operation is used for the amplification of current. From the above discussion, we can say that the transistor works as an on-off switch in saturation and cutoff mode, whereas it works as an amplifier of current in active mode. In the saturation mode, both the junction of the transistor, emitter to base and collector to base are forward bias. In other words, if we assume two PN junction as two PN junction diode, both the diodes are forward bias in saturation mode. We know that in forward bias condition, current flows through the device. Hence, the electric current flows through the transistor. In saturation mode, free electron flow from emitter to base as well as from collector to base. As a result, a huge current will flow to the base of transistor. Therefore, the transistor in the saturation mode will be on state and act like a closed switch. The saturation mode of the transistor is used in switching operation for switching on application. In the cutoff mode, both the junction of the transistor, emitter to base and collector to base are reverse bias. In other words, if we assume two PN junction as two PN junction diodes, both the diodes are reverse bias in the cutoff mode. We know that in reverse bias condition, no current flow through the device, hence no current flow through the transistor. Therefore, the transistor is in off state and act like an open switch. The cutoff mode of the transistor is used in switching operation for switching off application.
So I will explain about the three basic configurations of BJT. BJT is a current control device which is mainly used for application and switching purpose. There are three ways to connect this device with external electronic circuits, which are common base configuration, common collector configuration, and common emitter configuration. Common base configuration, where the common base is shared between input and output signal. Voltage is applied at the emitter base junction and corresponding output signal is obtained at the output across the base collector junction. The base voltage is connected to some reference voltage or can be grounded in some cases with the intention of making common base between input and output signal. Following figure shows that the circuit diagram of common base configuration. Current at the emitter side is quite large, where electrons are diffused into the base terminal. These electrons make a pair with some hole present in the base, while most of them leave the base and are collected by the collector. This type of transistor comes with remarkable high voltage characteristics, which don't make it an ideal choice for many applications. In this configuration, an output and input voltage is in line with each other. The input characteristics of this transistor are quite identical to forward bias diode, while output characteristics are similar to a regular diode and come with a high output to input resistance ratio. Common collector configuration is also known as voltage follower, where the input is applied at the base terminal and output is taken from emitter terminal. This configuration is mainly used for impedance matching, as the input impedance of this configuration is very high, while output impedance is very low. Common collector configuration is termed as non-inverting amplifier, where output signal and input signal are in phase with each other. The current gain of this transistor is very large because the load resistance is at the receiving end of both collector current and base current, making it suitable for application purpose. Hence, very little voltage gain around unity can help in producing very large current gain. The following figure shows that the circuit diagram of common collector configuration. Common emitter configuration is widely used in transistor-based amplifier, where an input signal is applied between emitter and base, while the output is taken from emitter and collector. This configuration comes with highest current and power gain, which makes it an ideal choice for application. Input impedance is connected to forward bias PN junction, which shows low value, while output impedance is connected to reverse bias PN junction, which shows high value. Common emitter configuration is termed as inverting amplifier circuit, where an input signal is out of phase with the output signal. Following figure shows the circuit diagram of the common emitter configuration.
Advantage of BJT. First, high driving capability. Second, high frequency operation. Third, digital logic family has an emitter coupled logic used in the BJT as a digital switch. Fourth, there are low forward voltage drop. Disadvantage of BJT, it has very complex base control. Hence, it may lead to confusion and requires skillful handling.